So in this lesson, we will discuss on how to identify if a given expression is a one-to-one function. So we already defined one-to-one function. So one-to-one function is wherein for every unique value of x, there is a unique value of y. Hence, if you have a domain which is x sub 1, so the function of that x sub 1 will not be equal to the function of the x sub 2. So you will not expect any same y values to be paired on two or more different x values. Okay, so that is why it is given the name a one-to-one function. Okay, now let's us try how to identify if an expression is a one-to-one function. So the best way to identify if an expression is a one-to-one function, so it would be good for us to create a table of values. So let us identify a table of values wherein we have x or the domain and the y or the range. Okay, so first let us try to identify the domain. Okay, so for this example, y is equal to x raised to 1/2, or which is also y is equal to square root of x. We could see that the domain could be any real number. However, there is a restriction. X should not be x should be greater than or equal to 0. Okay, so if we have a value of x that is less than 0, that will be a negative number, so we could not arrive or we could not solve for the value of y if we have a negative number, because a square root of a negative number will be an imaginary number. So we will limit our domain to 0 up to the positive infinity. Okay, so we have 0. Let us try 0, 1, 2, 3. Okay, so if x is equal to 0, y will be 0. If x is equal to 1, y could be 1 or it could be negative 1. If x is equal to 2, then y would be square root of 2, or it could be a negative square root of 2. Okay, and if x is equal to 3, it could be a positive 3 or it could be a negative 3. Okay, so with this table of values, we could see that for every value of x, there are multiple values of y. Okay, so for example, if you have x value of 1, it could be positive 1 or negative 1. Hence, this is not a one-to-one function. So this is a one-to-many relation. Okay, so one-to-many relation because you have one unique value of x, but there are multiple values of y. Now let's have other examples. So if y is equal to x squared, so let us create a table of values. So x is equal x and the domain and the range. So x could be any real number, so there will be no restriction. Okay, so if you have x is equal to negative 2, negative 1, 0, 1, and 2. So if x is equal to negative 2, y will be positive 4. Okay, if x is equal to negative 1, y will be equal to 1. If x is equal to 0, will be 0. X is equal to 1, it will be 1. and if x is equal to 2, y will be 4. So we have, for example, you get negative 2 and positive 2. As you could see, we have two unique values of x, yet it arrived to a similar value of y. So this is a many-to-one correspondence. Okay? So hence this expression y is equal to x squared is a many-to-one correspondence. Okay? So let's have another example. If y is equal to x cubed, for this there will be again no restriction. Just set x will be any real number. So I have negative 2, negative 1, 0, 1, and 2. Okay? And for y will be 4. I'm sorry, this will be not 4. Negative 2 cubed is negative 8. Y x is equal to negative 1 will be negative 1. X is equal to 0 will be 0. X is equal to 1 will be positive 1. And if x is equal to 2, it will be positive 8. Okay, so for this table of values, you could see that for every unique value of x, there is a unique value of y. So there is no repetition of y values for each given domain. Hence, this is a one-to-one correspondence. Okay, so the probable technique that you can apply is that if x is raised to an exponent, let's say exponent is an integer. Okay, so if the exponent is an even number, there is a it is typical that the correspondence will be many to one. Okay, if the exponent is odd number, it is more likely to be a one-to-one correspondence. Okay, now let us try to identify if a graph is exhibits a one-to-one correspondence. Okay, so this is the rule. So if you want to identify if a function, if an expression is or a relation is a function, it should satisfy vertical line test. Okay, so it should satisfy vertical line test. So again, a vertical line test is when you draw a vertical line at any point of the graph. The vertical line only passes to one point of the graph. Okay, so if it passes the vertical line test, so yes, it is a function. So it will be a either many to one, or it could be a one to one. If it does not pass the vertical line test, then it is not a function. So it might be a one to many correspondence or one to many relation. Okay, so many to one function or many to one correspondence will not pass a horizontal line test. Okay, so similar to vertical line test, if a horizontal line test passes only to one point of the graph, then it is a one-to-one correspondence. Okay, so this will be our test in order to identify if it is a one-to-one correspondence. Okay, so let us try. So if I draw a vertical line on this graph, so at any point of the graph, just draw a vertical line. Okay, as you can see, it passes to 2 points of the graph. Hence, this is not a function. So no need to perform horizontal line test. So it is understood that this is not a function. This is absolutely a one-to-many correspondence. Okay? So let us identify this second graph. I drew a vertical line. So at any point of the graph, this only passes at one point of the graph. Okay, let's say I drew a line here. So it only passes to one point of the graph. So if you draw at any point of the graph and it only passes a one point, then it is considered as a function. So this is a function. How about we identify if it is a one-to-one correspondence? Okay, so in order to identify a one-to-one correspondence, again, draw a horizontal line test. Okay, since it passes to more than one point, then this is not one-to-one. Okay, now let's have this example. I draw a vertical line. This passes only one point, then this is a function. I draw a horizontal line, any point of the graph will do. So I decided to draw it here. And it only passes at one point. Then this is a one-to-one. Okay, again, draw again, line. So this it only passes at one point. So if I draw again a line, so let's say this one. So I'm pretty sure that does not passes at more than one point. It just so happened that our graph is asymptotic at this line. Okay, so it passes, since it passes only one point, then this is a function. It passes only one point the vertical line test, and it passes only one point at the horizontal line test, then this is a one-to-one function. Okay, so let's have other examples, but not in a graph form. So which of the following is a one-to-one function? So y is equal to x raised to 4 minus 4. So I just check if the exponent of the variable x, because we only have one x here. So the variable x has an even numbered exponent. So even if you try to create, it will be better if you can draw or write a table of value. So to check also the availability of the y values. Okay, so this is not one-to-one. Y is equal to 2x plus 3. X is raised to 1. So add number, it will be a one-to-one. Okay, 0, 1, 1, 2, and 2, 3. Unique value of x's, unique value of y's. So this is one-to-one. 10, 5, 0, 10, 0, 5, 4, and 0, 0. So let us check. Unique value of x, but 0 and 0 reoccur. So this is not one-to-one. LRN, or learner's reference number. So for every student, there is a unique value of LRN or unique LRN. So this is a one-to-one. And subject teacher to student. So the subject teacher might teaches multiple set of students. Okay, multiple class sections, and same with the students, they might have multiple subject teachers. So this is not one-to-one.